Hi class, welcome to exercise 5C, factoring monic quadratic trinomials. In this lesson, our examples and pre-learning will be the example 8, factorising trinomials of the form x squared plus bx plus c, otherwise known as monic. And your pre-learning for this example will be questions 1, 2, 3 and 4 in the new book and 4, 5 and 6 in the old book. That's quite a few questions there. And then we'll work on example 9, where we'll be simplifying algebraic fractions using some of the techniques we learned today. And your pre-learning for this example will be questions 5 and 6 in the new book and questions 7 and 8 in the old book. This is the second of 3 lessons about one method of factorising. So make sure you're very confident with the concept of grouping that we learnt in the last lesson. Alright, I'll see you in the introduction. We know that if we expand the binomial product x plus p times x plus q, we'll get x squared plus p plus q times x plus p times q. So for a monic trinomial, x squared plus bx plus c, and monic just means 1 times the x squared. If c was equal to p times q and b was equal to p plus q, then our monic trinomial is equal to x squared plus p plus q times x plus p times q, which expanding those brackets gives us x squared plus px plus qx plus p times q. And then by grouping these terms, I can take the common factor out of each term and we'll end up with x times x plus p plus q times x plus p, which gives us x plus q times x plus p. And we know this from our last lesson. So this idea is the basis for the method that we're going to learn how to factor a monic trinomial. And by monic, of course, we mean x squared plus bx plus c. Okay, so nothing multiplying that x squared. So for this method, we need first find the factor pairs of c, then find out which factor pairs of c sum or add to b, and then we can factor by grouping. So why find the factor pairs first? Well, that's because there's finitely many factor pairs, but infinitely many summing pairs. So for example, factor pairs of 6 are 1 and 6, or 2 and 3, and summing pairs of 6 are 1 and 5, 2 and 4, 3 and 3, or 6 and 0, 7 and 1, 8 and minus 2, and on and on and on. And there's no reason why I chose 6. This is true for any whole number. Now, it is important that you consider negative factor pairs because 1 and 6 and 2 and 3 are not all factor pairs of 6. Minus 1 and minus 6 and minus 2 and minus 3 are also factor pairs of 6. So it's always important to keep an eye out for those negative factor pairs. But negative factor pairs are very important for trinomials like x squared minus 6x minus 72, where we've got a negative c. So what are the factor pairs of minus 72? Well, let me write them out quickly with the magic of post-editing. So of course, each one of those pairs multiplied together equals minus 72. But don't forget that the exact same numbers, except for having the sign switched on both of them, are also factors of 72. So we might as well actually try and factor this trinomial. So which of these factor pairs add up to minus 6? I'm starting from the start. 1 minus 72 is minus 71, so it's not that. 2 minus 36 is minus 34. 3 minus 24 is minus 21. 4 minus 18 is minus 14. And 6 minus 12 is minus 6, which is exactly what we're looking for. So we can start with x squared minus 6x minus 72 and rewrite minus 6 as 6 minus 12 because I know that minus 72 is equal to minus 12 times 6. So if I expand the brackets above, and then you can see I can make 2 groups here. And the group on the left has a common factor x, and the group on the right has a common factor of minus 12. So let's factor those out. And both of these terms have the common factor x plus 6. So we end up with x minus 12 times x plus 6. And we'll see that in a lot more detail in the examples. But here's some negative factor facts. And that is, if c is positive, both factors are positive or both factors are negative. And if C is negative, one factor is positive and the other's negative. And it looks like pro tips are going to enter the introduction for the first time. And that is, if you're unsure at all about your answer, then you can check your answer by expanding it. So our answer was x minus 12 times x plus 6. And using FOIL, that's equal to x squared plus 6x minus 12x minus 76. Minus 72. And then by collecting like terms, we end up with x squared minus 6x minus 72, which is exactly what we started with. Now, one question you might ask is, does order matter? Well, yes and no. And that depends on what sort of order we're talking about. Now, trinomial order definitely matters because we like to see the powers of x getting smaller from left to right, i.e. x squared plus ax plus bx plus c times x to the 0, because these represent x to the 2 and these represent x to the 1, and this one represents x to the 0. So you normally don't write that x to the 0 in there because that just means 1. So that's one type of order. But what about if instead of writing x squared plus 6x minus 12x minus 72, is it okay to write x squared minus 12x plus 6x minus 72, i.e. swap around 6x and minus 12x. Let's test that out by grouping them, then taking out the common factors of both of them, and we end up with x plus 6 times x minus 12, which is exactly the same answer. Therefore, it doesn't matter which order we write the linear terms. And by linear, I mean x to the power of 1. So let's do algebra examples side by side. So on this side, I'm going to write x squared plus ax plus bx plus ab. And on the other side, I'll write x squared plus bx plus ax plus ab. So all I've done there is swap the a and the b around. So doing some grouping, on the left here, I end up with x times x plus a plus b times x plus a. And on the right, we end up with x times x plus b plus a times x plus b. And then we end up with x plus b times x plus a on one side and x plus a times x plus b on the other side. And this is clearly the same thing because order doesn't matter for multiplication. In other words, it's associative. Now, in our next lesson, we're going to learn how to factor a times x squared plus bx plus c when a is not equal to 1. But in this lesson, if you see a is not equal to 1 in a trinomial, you'll need to find a common factor for the whole trinomial. So for a times x squared plus bx plus c, if a is a factor of b and c, i.e. b is equal to a times p and c is equal to a times q, then a times x squared plus bx plus c is actually equal to ax squared plus apx plus aq, which becomes a times x squared plus px plus q when we take out the common factor. And this now leaves us with a monic trinomial. Anyhow, you'll see in example 8 part C a more numerical demonstration. Anyhow, we should stop the introduction here. Let's get on to the next sections where we get a chance to actually really work with these ideas. See you there. To factor the trinomial x squared plus bx plus c, we need to find the factor pairs of c that sum or add to b. But of course, we should not forget negative factors. And that's because minus a times minus b is equal to a times b. So for example, minus 2 times minus 4 is equal to 8, which is also equal to 2 times 4. And also, if all terms in the trinomial have a common factor, then you need to factor that out first. So for example, a times x squared plus abx plus a times c is equal to a times x squared plus bx plus c. Alright, let's get on with example 8, where we'll be factorising the follow monic trinomials. In part A, the trinomial is x squared plus 8x plus 15. So we're going to find factor pairs of 15, and they are 1 and 15, 3 and 5, minus 1 and minus 15, and minus 3 and minus 5. And we need to find a pair that adds up to 8, And sure enough, 3 and 5 add up to 8. So we can rewrite that 8x as x squared plus 3x plus 5x plus 15. So essentially we haven't changed anything. The 8x has become 3 plus 5x. All right, and the next thing we want to do is some grouping. And then we'll take out the common factors, which is an x on the left group and a 5 on the right group. And we end up with this because x times x is x squared, x times 3 is 3x, 5 times x is 5x, and 5 times 3 is 15. And clearly x plus 3 is a common factor, so our answer is x plus 5 times x plus 3. All right, that's done. All right, let's have a go at part B, where we have x squared minus 5x plus 6. So the factor pairs of 6 are 1 and 6, 2 and 3, minus 1 and minus 6, and minus 2 and minus 3. And obviously minus 2 and minus 3 add up to minus 5. So if we rewrite this expression as x squared minus 2x minus 3x plus 6, all we've done is change the 5x to the minus 2 minus 3x. And once again, we can group those. And x squared and minus 2x have an x as a common factor, and the minus 3x and plus 6 have minus 3 as a factor. And we can see that both of these numbers are multiplied by x minus 2. So we can complete the factorising as x minus 3 times x minus 2. And that's done. Let's move on to part C, where we've got 2x squared minus 10x minus 28. And clearly 2 is a common factor. So let's take that out. Now factor pairs of minus 14 are 1 and minus 14, 2 and minus 7, minus 1 and 14, and minus 2 and 7. And 2 and minus 7 add together to make minus 5. So we can rewrite this trinomial as 2 times x squared plus 2x minus 7x minus 14. And once again, you can see that minus 5x has become plus 2x minus 7x. And we've got two groups here. So taking out common factors, we end up with 2 times x plus 2 minus 7 times x plus 2. And then bringing that all together, we end up with 2 times x minus 7 times x plus 2. And we no longer need these brackets here. All right, let's have a go at part D, where we have x squared minus 8x plus 16. Now I think it's time for a perfect square alert. And I say that because x plus a squared equals x squared plus 2ax plus a squared. And x minus a squared equals x squared minus 2ax plus a squared. And 2 times minus 4 is minus 8, and minus 4 squared is 16. And you can see we've got a minus 8 and a plus 16 here. So clearly this is equal to x minus 4 squared. Now it might not look like a shortcut because of all the writing I did on the side, re the perfect square alert. But if you see it, you can just pop it straight in there, okay? Now at this stage we might stop and have a check. Let's have a look at what we did in question C, where we had 2x squared minus 10x minus 28 becoming 2 times x minus 7 times x plus 2. So if we expand these brackets, we end up with 2 times x squared plus 2x minus 7x minus 14, just using FOIL. Then collecting like terms, we get 2 times x squared minus 5x minus 14. And multiplying that 2 through, we end up with 2x squared minus 10x minus 28, which is exactly what we started with. So that's a relief. Now that's just an example of me checking one of these. If you have any doubts on any of your questions, always double check by expanding your answer. It's very helpful on some tests. Anyhow, right now you should pause that video and work on questions 1, 2, 3, and 4 in the new book, and questions 4, 5, and 6 in the old book. Now some of these questions have a lot of questions. You don't have to answer them all. I don't want you to spend 2 million years working on this exercise, but you should do enough to feel confident, and that usually will include doing some of the more difficult ones like the bottom row. All right, I'll see you in the next section. Now, at first glance, some of these can look super challenging, but we now have the tools to make it easy. And that's because x plus a is just a number. So if you have x plus a times x plus c divided by x plus a times d, well, you can just cancel them out because x plus a cancels as a common factor. And then we're left with x plus c divided by d. So in this section, we're going to have numerators and denominators with trinomials. All you're going to have to do is 1, factorise them, and 2, cancel out the common factors. Alright, let's move on to example 9, where we'll simplify the following algebraic fractions using factorisation. Alright, part A, we have x squared minus x minus 6, all divided by x plus 2. So clearly we've got to factorise the trinomial at the top. So the factors of minus 6 are minus 1 and 6, minus 2 and 3, 1 and 6, and 2 and minus 3. And so we're looking for a factor pair that adds up to minus 1, and I can see that 2 and minus 3 equals 1. Sorry, minus 1. So therefore x squared minus x minus 6 is equal to x squared plus 2x minus 3x minus 6. And taking out common factors of the two groups, we're now left with x minus 3 times x plus 2. So now I can substitute this in for the numerator. And x plus 2 is a common factor. So we're left with x minus 3. So yeah, that very complicated looking fraction actually reduces down to just x minus 3. Alright, let's move on to part B, which is a real doozy. X squared minus 9 divided by x squared minus 2x minus 15 multiplied by the fraction of x squared minus 4x minus 5 divided by 2x minus 6. So I'm not going to go through each one of these, but I do know that x squared minus 9 is x plus 3 times x minus 3 using difference of perfect squares. 2x minus 6 has a common factor of 2. Factor pairs of minus 5 include minus 5 and 1, and that adds up to minus 4. And x squared minus 2x minus 15 is equal to x minus 5 times x plus 3. So substituting all these values back into this fraction, I now get x plus 3 times x minus 3 in the place of x squared minus 9. And x minus 5 times x plus 3 in the place of x squared minus 2x minus 15. And x minus 5 times x plus 1 in the place of x squared minus 4x minus 5. And 2 times x minus 3 in the place of 2x minus 6. So don't forget we can cross cancel with the multiplication. So I've got an x plus 3 on the top and the bottom. And I've got a x minus 3 on the top and the bottom. And an x minus 5 on the top and the bottom. And that's all the cancelling we can get. So we're now left with x plus 1 divided by 2. Now I'm not going to do it here, but if you do want to check, I suggest you pop in 3 or 4 individual numbers. So by that I mean substituting a number in for x. So for example, if x was equal to 1, our answer at the bottom would be 1 plus 1 divided by 2 is 1. And at the top we would have 1 squared minus 9 is minus 8. Divided by 1 minus 2, so on and so forth, okay? So you would just sub in a number for x in the answer and the question. Alright, so I should better let you pause that video now and get on to do questions 5 and 6 in the new book or questions 7 and 8 in the old book. And then please come back so we can summarize that lesson. Alright, we still have one more lesson to go in learning how to master this grouping method for factoring quadratics. So please make sure that you really master this stage of grouping. Okay, so for this lesson, a successful student will be able to identify a monic quadratic trinomial, understand the relationship between expanding brackets to form a trinomial, and factoring a monic trinomial. Know how to factorise a monic quadratic trinomial, And finally, be able to simplify algebraic fractions by first factoring and cancelling out common factors. Alright, keep up the great work, students. We'll see you in the next lesson, whether that's in a video or in class. Bye.